we're going to check out the LOHAS RGBW bulb and the warm white and cool white bulb and flash them with ESPHome. We'll also check out a new bulb with Tasmota. Let's get to it. So with all these bulbs, they do use the Tuya Smart Life app. So we have converted them using the Tuya convert process over the air. If you haven't already seen that, we'll leave the link in the description of the video below. But it's a process that you use to flash these bulbs over the air without any soldering to the bulb itself at this time. One thing to note, if you do watch that video, make sure and check the description of the video, as I do update it from time to time. I would highly suggest downloading the bin file and putting that on your Raspberry Pi, as it makes Wi-Fi Manager default on Tasmota, which means that no matter if you do mess up on the SSID or password in your Wi-Fi, that the bulb will always come back in access point mode and allow you to reconfigure that bulb, and you won't potentially brick your bulb since there are no buttons to press to hard reset these back to default. One thing that people do ask from time to time is these bulbs are shown as being UL listed on the box, and they are stamped on the side, if you can see it here, as being UL listed. So if you need the UL listed bulbs, it'd be great for you. Now with that said, I will say these LOHA bulbs, I did find the colors very vibrant and bright compared to many other bulbs that I've used. So these probably are my favorite bulbs at this time, are these LOHA bulbs, being the color or the cool white, warm white. They're very bright bulbs. So let's take a look at this one. This is the color bulb. So looking at this color bulb, you can see there's the ESP8266 chip right here. There's the flash memory. And then there's the two My9231 LED drivers. Or if you watched the previous smart bulb video, that one light bulb and the downlight had one LED driver, the 9291, which is a variant of the 9231. Now, as you can see here, there's the white LEDs, the reds, the greens, the blues, and the whites, and they go along the sides. Now, one thing to note, this one also offers the ability, as for backup if needed, they'd label it for you, the RX, the TX, the 3.3 volts, and ground, and then GPIO 0. So if you held that to ground while applying power over 3.3 volts, then you could flash this using the old soldering methods that would be very reliable in case you did happen to brick the bulb by putting in some wrong code or whatnot during this process. You can solder to this bulb if you're careful to do it. Now this is the tunable bulb, the warm white to cool white bulb, also by LOHAS. This one's a little different, as they refer to them with a Y as the yellow LEDs, then the white LEDs, and they're interlaced around the edge of the bulb. Again, you got the ESP8266, you've got the flash memory, and this has that variant of the My9231 for the LED driver. Again, for backup purposes, you do have ground, RX, TX, 3.3 volts, and GPIO 0 if you want to flash this with a USB flasher, if you're not going to use the OTA method at this time with the Tuya convert. So we've already done the Tuya convert on all these bulbs. This process is very simple. You just do an on process, and that puts them into pairing mode, and then you can use your standard Tuya convert, which again we'll link in the description of the video. So we're going to check out Tasmota on this bulb using the available firmware at the time of the recording of this video, and we'll show you one issue we run into, and then we'll put ESPHome on it to correct the issue. Once you have Tasmota flashed the bulb and configured, you can go to the console, and much like we showed in our previous video of the smart bulbs, we did change it to a AI light module and hit save and rebooted the bulb. And now we need to go to the console to check the colors to see if we can see all the channels of the bulb. So first, we would start out with just doing a color value in the first slot. We'll do 10, 0, 0, 0. Well, right off the bat, we can see there potentially could be a problem, as only half of the LEDs on the one channel are lighting up. So we'll move that down the line. Now it switches to the white LEDs, again only half of them, and we'll do 0, 10, comma 0. Now you can see the other half light up. And then same thing on the white LEDs. Now currently at the time of this video, there's no way to copy from one channel to another in Tasmota. So today we're going to flash this one with ESPHome, and I'll show you how to copy the channels to have both white channels map to each other along with both warm white channels map to each other. So to get started with ESPHome, if you go to the ESPHome documentation, there's a section that says Getting Started through LOHAS add-on. If you go into here, there's a section for installation. You just copy and paste this into your repository and add it into LOHAS. There are other methods using the Docker containers, such as with Unraid or just straight Docker. You can install the Docker container yourself if you search the Docker container ESPHome on Docker Hub. So once you have it installed, we'll need to go to the ESPHome dashboard. Once you're in the ESPHome dashboard, we'll need to do an add node. You may have other nodes already from adding other switches or sensors or whatnot. So hit the plus, we'll add a new one. We'll call this the LOHAS CWWW for cool white, warm white. Continue. We'll leave it as generic ESP8266. Hit continue. You need to put in your Wi-Fi SSID and password. We'll hit continue. And then we'll hit submit. And we'll leave the port to over the air, since we will be compiling this and we will download the binary and flash it through the Tasmota GUI. So first thing, let's go check to make sure that everything is correct in here. I hit edit. We'll make sure the name is correct. Double check again your Wi-Fi credentials, and we'll leave everything else as default. And as mentioned previously, I will be using static IPs, so I'm going to go copy and paste in the static IPs. If you don't have that issue, you don't have to use a static IP for each ESPHome device. So we'll hit save, close. We'll validate it to make sure it becomes back valid. Good enough. We'll hit close. Now we do need to add in the My9231 driver information. So if we go back to the documentation of ESPHome and we'll search for 9231, we'll find the My9231 section. If we scroll down, we can find the example from the Sonoff B1 bulb to use as example to copy and change the values for what we need. So if we take this section here, we'll copy it to our information. We need to change the GPIO pins as shown for AI light. It'd be GPIO 13 and GPIO 15. Now the number of channels for this bulb is going to be 4. The number of chips is going to be 1. We'll save it. Go back to the documentation because now we need the output. So copy this. And we'll put it below the My9231. We won't have colors in this bulb because it's just warm white and cool white. Because remember, there's 2 channels of cold white and 2 channels of warm white. So do output CW1, and then we'll do output CW2, output warm white 1, and output warm white 2. Remember, they were interlaced when we tried them in Tasmota. So if you do cool white as 0, and then the next cool white is actually 2, then the warm white is channel 1, and the warm white 2 is channel 3. So you come up with 0, 2, 1, and 3. Next, we need to go back down to the documentation, and we'll need to copy in the light section. Put it below the output. And the platform is going to be CWWW for cool white, warm white. The name, we'll call this LOHAS CWWW1. We won't have a red channel, we won't have a green channel, and we won't have a blue channel, of course. And according to the description on this bulb, the cold white is 6500 and the warm white is 2000K. Now, to map cold white to warm white, you can only map one channel to one. Again, you'd have the same issue with Tasmota, that you would only have half of your bulb working. So thanks to Otto, he did send a custom component which allows you to dual map channels in ESPHome. And I will put a link in the description of the video which shows all of how to copy and paste that into a file. And you do need to put that in your ESPHome folder in your config folder on your Home Assistant device, wherever ESPHome is stored, whether it's in a Docker container or in HASS.io. You should see in your config folder in ESPHome. So once you find your folder where you have ESPHome, like say in your Home Assistant config folder, if you're using say the Samba share component, if you would just copy the copy chan.h into the same folder, it should be right next to your LOHAS CWWW, which we're just starting. So now that you have that in there, we need to include it in the code. If you'll copy and paste from the description of the sample file, we're going to be using an includes, which is the copy chan.h file we just copied into our shared folder for ESPHome. This will allow us to use the copy channel output for the bulb. So under the output, you're going to add two custom sections. The first custom section is going to take output CW1 and output CW2. It's going to output it into an ID just called CW, which we will use in the light component right below. So now we need another one for warm white to copy those two channels to bring them down to 1. So this is going to take output WW1 from here and output WW2 from here. It's going to copy it, it's going to bring it into WW. So now in the light component, we need to reference for cold white just CW and the warm white WW. So whenever you apply color to WW, it's going to break it out to the two channels and light up both sides of the bulb properly. And same thing with the cold white. So we'll save this, we'll close it, and we'll do a validate. Comes back as valid, and then we'll click close. Next, we need to grab the binary and we're going to flash it through Tasmota GUI. If you click the three dots right here and hit compile, it may take some time to compile depending on your computer or Raspberry Pi. But once it compiles, we're going to utilize the download binary button when it's finished. So we'll let this compile. Once it compiles, we'll download the binary. It downloads as LOHAS CWWW bin. Then we'll go back to the Tasmota GUI for our bulb. We'll go to main menu. We'll go to firmware upgrade. We'll choose file. We'll navigate to where you download the bin file. We'll hit open, and then we'll hit start upgrade. Once it's successful, we'll go back to the ESPHome dashboard. We'll hit show logs. And once the log fills out, we know we have a successful connection to the bulb. Now let's go into Home Assistant and add this integration into our GUI. So we'll go into Home Assistant, go to Configuration, go to Integrations, go to ESPHome Configure. We'll use 10.22, which is the IP address, and your IP will differ. You can use it in the log to find out the IP address. Hit Submit. Got success. And now we have our LOHAS CWWW bulb. Now let's check the channels. And at first glance, if you don't have all the LEDs lighting up correctly, just try to power cycle the bulb at first. I have found when going from Tasmota back to ESPHome that the LED driver will get confused or hung up and it will need a reboot. But once you've done that one time, it should be fine after that. So we have it all the way on cool white. We'll slowly slide it over in the middle, and you can see it lights up all the LEDs half and half. And then if we slide all the way to warm white, we get just the warm white. And there we have it. We have all of the LEDs on the LOHAS bulb. Now let's check out the LOHAS color bulb. So for the LOHAS color bulb, we had the same issue as there was two channels of cool white. And there was only one set of LEDs appearing if we didn't also use the same copy command. So again, we won't go through the whole configuration of that. We will just leave a sample in the description of the video where you can download that file and change up the Wi-Fi SSID and password and names to your liking and utilize this same bulb with ESPHome. So as you can see here, once it's configured, you get the white value, which will change the white channel of the bulb. Also, once you change the brightness, you can get all the various colors of the LEDs, which it does look much better on camera once you have the diffuser on it. So you've got your blue, your red, and like I said before, the colors are very vibrant on these LOHAS color bulbs and very bright on the white as well. So one last bulb we'll cover is that Anute bulb, which will be in Tasmota using PWM. So with the Anute bulb, it actually has cool white and warm white LEDs. It has a little different Wi-Fi module, which you're familiar with. It's the TYWE3S if you've watched other videos in this channel. But you can see it would be difficult to solder. Luckily, this does work at this time with the 2U convert, and you can put Tasmota on it. It does utilize PWM, which you could use with ESPHome, but we're going to show it in Tasmota just to show you both firmwares for controlling bulbs. So the bulb is pretty simple. Has cool white, warm white, and it's interlaced every other one with cool white, then warm white, and so forth. So let's check it out in Tasmota. Once you finish the 2U convert process and you get Tasmota on it, typically, as I've shown in one of my live streams when trying to figure out new devices, you would go to the configuration and the configure module. You'd make sure it's on generic, and you'd start trying out all the various pins of the different modes to find out which one turns on the light, which one may turn on the color, etc. One new feature in the development version of Tasmota, which you can get the development binary files pre-built for you off of the Tasmota GitHub page, is the one-liner templates. Instead of trying to figure all this out, what you do is go to Blackadder's Tasmota device template repository. Blackadder helps maintain the Tasmota wiki for all the various instructions and the set options and commands, etc. So this is all tied into the Tasmota wiki. For this particular bulb, if you look under light bulbs and lights, you'll see there's the Anute CWWW 60 watt bulb. I've submitted this to Blackadder using the add new template function, which if you do have a device that is not listed on here that you've figured out, go through and submit the template with the little one-liner, which we'll show you in a second here from Tasmota itself, so other people can enjoy that same device in simple configuration. So all you do to configure a device that's in the repository is click the device name and copy this one line of JSON. There possibly could be additional information down here about the bulb or device or etc. Maybe some different rules or set options, so be sure and check those out. Also, they do have links to where different people have purchased these devices if you just want to look through and find different devices. So once you have this JSON on your clipboard, we'll go back to the Tasmota GUI, the configuration, click on Configure Other, and in the template box, you'll need to copy and paste over, if there's anything else in there, the template that you copied from the repository. So paste it, click the Activate check mark, and hit Save. You'll see at the top it changes it to that module name already. And once it reboots, your bulb is configured. And you'll notice if you go look in the configuration and configure module, that it has module 0 for your bulb. Now there's no other pins to configure because of course it's the bulb. If you did want to edit the template, you can go to Configure Template and edit the actual template itself. So now let's give the bulb a shot and see how it works out. We'll go ahead and turn it on. And there's a slider for cold and warm, and you can see all of the cold LEDs are on. We can slide it over halfway. You can see the warm light up as well, and then the cool shut off going all the way to warm. And we do have the darkness and brightness to adjust as well. So pretty simple, no crazy configuration or anything, just copy that one line in and be done. Now let's go check it out in Home Assistant. So I will leave a link to the template they use if you want to manually add it to Home Assistant through MQTT, but you can just copy it straight in. So once you copy that in, restart your Home Assistant, you of course will get the bulb, and you'll get the slider for the warm and cool, and then of course you do get the brightness. So typical for a bulb, and you get the on off, and that's it. Very simple to configure the Anute bulb, which does your warm to cool white color tuning. So in case you missed it, be sure and check out the live stream where we did the Fate electric bulb, and we also did the mercury bulb in Tasmota, since they utilize the SM16716 LED driver. So that's all there is to it. Appreciate you watching this little series on smart bulbs. They're not always a bad thing to use. I use them in several different lamps, and you can also use them in various other places. Definitely smart bulbs are the way to go if you can't change the light switches out. So if you're not already a subscriber, make sure and subscribe, hit the bell icon, and check out our next video, and y'all take care.